Today we are going to learn comparing the linear, quadratic, and exponential functions to learn how can you tell that one function is linear or is a quadratic or is a exponential functions from the graph or from table of values. So first thing we want to use table of values to compare the three functions. The first one is linear. So we are going to fill in this table of values. So when x equals -2, we sub in -2 here. You will have y equals -2. And x equals -1, sub in y equals -1. X equals 0, sub in y equals 0. So just continue. You will see y equals x will give you the same value for the x for y. So the third y means the difference of the y. So you see the left side, we call this one before it's run, and for the right side, the difference of y, we call it rise. Rise over run give you the slope. So from this -2 to -1 give you 1. So right 1, right 1, right 1, right 1, right 1. And the y is up 1. Okay, the difference of y is up 1. Okay, and how you do the calculation is subtraction. The bottom y subtract the top x. So 3 minus 2 give you 1. 2 minus 1 give you 1. Okay. Then from this linear function, you will see that first differences are same. So that's why we call the first differences. Okay. So first differences are same. They are equal. Okay. And in other ways, it means the rise over run for all the 2 points will give you rise is 1 over 1, so the slope is 1. They have the same slope, it will give you a straight line. Okay, so that is for the first linear equation. The second one is quadratic. Y equals x squared. So when x equals -2, we sub in -2 squared give you 4. -1 sub in -1 squared give you 1. 0 squared give you 0. 1 squared give you 1. 2 squared give you 4. 3 squared give you 9. So for the x, still the run is 1. So each one increased by 1. Okay. And for the first difference of the y value is subtraction of the y. So the bottom y value subtract the top y value, you will have -3. From 1 to 0, 0 minus 1 give you -1. 0 to 1 is up 1, 1 to 4 up 3, 4 to 9 up 5. You will see for quadratic functions that first differences are not same. So if they are not same, means the slope is not same, so it's not linear. Then we want to see the second differences. The second differences means subtract the first differences. So -3 to -1 is -3 minus -1 minus -3 give you +2. And from 91 to 1 is up 2, 1 to 3 up 2, 3 to 5 up 2. So you will see for quadratic function, the second differences are same. So in future, if a set of data is given, then how can you tell it's linear or quadratic? You just make sure that for the x, all increased by 1 or 2 or same, then you check the y increase by same or not same, but second differences same, then you will be able to tell it's linear or quadratic. And the next one is last chapter we have learned the exponential functions. The x is at exponent. We call this one exponential functions. So although we didn't discuss this, the graph of exponential functions, now we are going to learn how to graph it. So create a table of values, the x value from -2 to +2 enough, but I have another number there. You have more than enough points. So we study -2 here. You will have 2 to the exponent -2. Use your calculator, it will give you 0.25. Then the next one, 2 to the exponent -1, use your calculator, give you 0.5. 2 to the exponent 0, any base to the exponent 0 give you 1, but the base cannot be negative or 0, okay? It's 1, 2, sub in 2 to the exponent 1 is 2. 2 to the exponent 2, 2 times 2 give you 4. And x equals 3, 2 to the exponent 3, use your calculator, you have 8. So on your calculator, how you type in is 2, then you look for the exponent button. Sometimes it's x to the y, exponent y, or y to the exponent x, or a to the exponent b, or some calculator you may just have this up arrow. Then you put the -2 here equals, it will give you 0.25. This is how you do the calculation on your calculator for a power 2 to the exponent -2. So the commons are the difference. We are going to do the subtraction. 0.5 minus 0.25 give you 0.25. 1 minus 0.5 give you 0.5. 2 minus 1 give you 1. 4 minus 2 give you 2. 8 minus 4 give you 4. So the third y means first the difference. Difference means subtract. Okay, minus. Then we are going to see if we continue to find the second difference. Since you will see they are repeating, it will give you 0.25, 0.5, 1, 2. So you will never ever have the same differences. Now we are going to see the ratio. Ratio means divide, the quotient, division, okay? So we are going to focus on the y value, then we do the division. 0.5 divided by 0.25. The bottom y value divided by the top y value give you 2. The 1 divided by 0.5 give you 2. 2 divided by 1 give you 2. 4 divided by 2 give you 2. 8 divided by 4 give you 2. So you will see the ratios are same. So for exponential function, the property is the ratios are same. So from these three different properties, you will be able to tell from a table of values if the first differences are same. First differences means a difference of y. You subtract the y. If they are same, it's linear. If first difference is not same, but subtract again, you have the second difference is same, then it's quadratic. And if you have the first differences repeat with the previous y value, then we try the ratio. Do the division of the y value. Then if the ratios are same, then we know exponential functions. So this is what you need to know for today. from the table of values, how you can tell it's linear, quadratic function, or exponential function. Okay, that is what you need to know from table of values to tell what type of functions you are going to have. And the next one, we are going to see how what's the difference between among the three functions. So for the first one, we are going to use a table of values to draw it. So linear is 0, 0, 1, 1, negative 1, negative 1, negative 2, negative 2, 2, 2, 3, 3. Then you connect these points, you will see you have a straight line. This is linear. Linear means straight line. And for the quadratic, we are going to see negative 2, 4. This is 4, okay. Okay, it's not right. Okay, then negative 1, 1, 0, 0 is from the table values. 1, 1, 2, 4, and 3, 9. Okay, 3, 9, 4, 5, 6, 7, 8, 9. So 3, 9 will be here. And it's symmetric, so you will have another negative 3, 9 on the other side. And then you connect those points smoothly, you will have a problem. Don't use straight line, it should be curved. So this is y equals x squared. So we also call it U shape, okay? If you see U shape, either open up or open down, then we know it's quadratic, okay? So from the shape of the graph, so linear is straight line, U shape is quadratic. And after that, we are going to see how can we draw the exponential function. Exponential function negative 2, 0.25. So it will close to here. And the negative 1 is 0.5. It's half of the grid. And 0 is 1. So 0 is 1. 1 is 2. 2 is 4. 3 is 8. Okay. Then we are going to connect these points together. Okay. This is y equals 2 to the exponent x. So you will see that for the exponential functions, it's increasing or decreasing all the time. It's not turning, okay? It's curved and it's increasing. So for this one, exponential either increasing or decreasing. So that is exponential, okay? And the for increasing is when the base is greater than 1. So for example, 2 to the exponent x, 3 to the exponent x will be increasing. For decreasing will be the base is less than 1. Okay, you will have decreasing. This is exponential functions. And for quadratic is either open up or down. And for linear is either go up or going down, decreasing. Okay, so you have these three different types of graphs. You need to know that you are able to tell from the graphs given. So we are going to fill in this one based on the graph we just draw. So this one is just keeps going. Okay. And this one is open up. Just recopy that one here. And the exponential is just increasing. Let's go this way, okay? So based on these three graphs, we are going to fill in this chart. So domain means violate x, okay? This one, no, it keeps going infinity, negative infinity, positive infinity, we could write it as negative infinity, positive infinity for interval notation. And this one keeps going, so same thing, negative infinity, positive infinity, interval is negative, positive infinity. This one keeps going for x direction, so they are same. All the domains are from negative infinity to positive infinity. And the range is valid y value. So for this one, you will see up and down it keeps going. So you just change the x to y, then y is all real numbers, negative infinity to positive infinity. For the quadratic, it's a little bit different. Y, you have a minimum value, so it's y from 0, then go up. So the minimum is 0, the maximum is infinity. So from 0 to positive infinity and including 0. So you write it as intervals, it will be squared bracket 0, then positive infinity. Okay. And for this one is from is go up all the positive value and it doesn't cross x-axis, so it's from 0 to positive infinity, but it's open circle, so it will be 0, okay, 0 but no equal sign. Y positive infinity is bracket but not squared bracket, so it doesn't include y equals 0 point. So x-intercept means graph intersect with x-axis, so it's 0. So y equals 0, then x equals 0. So x-intercept means intersect with x-axis. X-axis is y equals 0. So this one, x-axis, the point of intersection is when y equals 0, you will see x equals 0. Okay. And this one, when y equals 0, there's no point intersect with x-axis, so it's none. Never ever, no x value. It doesn't cross x-axis. So y-intercept, it means when x equals 0 was a y value. So when x equals 0 on the y-axis, in this point of intersection with y-axis is y equals 0. So this one, when x equals 0 on the y-axis, point of intersection with y-axis is 1. Y equals 0. And this one, when x equals 0, the point intersection with y-axis is 1. Okay. So this one is a point of intersection with y-axis, that is called y-intercept. This one is point of intersections with x-axis. Okay, so asymptote is a new concept. It's only applied to this. So far, these three only apply to this exponential function. Asymptote means the graph approaches to a line closer and closer, but never ever cross it. So for linear and quadratic, we don't have a line that graph will closer to it, but never ever cross it. But for this exponential, this graph is closer and closer to the x-axis, but never ever cross it. So we call the x-axis y equals 0 is a asymptote for the graph. So the graph will closer and closer to the x-axis, but never ever cross it. So we call this x-axis is a asymptote. So the graph close to it, approach it. Closer and closer, but never ever cross it. Process. We call that line is asymptotes. And the general form for the linear equation is slope y-intercept form. For the quadratic equation, we could write it in standard form or vertex form. X minus p bracket squared plus q. And for this one, it's just y equals a dot b. Dot means times b to the exponent x. So a is a y-intercept, is initial value, and b is a base. Okay, for this exponential function. The graph just now I have. This is for the base function, parent functions, a simplest function in this family. Okay, and the graph for the parent and base function, that is a simplest graph in this family is y equals x squared. And this one is kind of just the base will be changing, so it just base greater than 1 is increasing. And if base is less than 1, it will be decreasing. So it's changing for different base. Table values, we have it on the top, so see above. Okay, so see above, we have the table values, see above. We don't need to repeat it again, okay? So this is for the first page. Now we are going to go to the next page. Next page, we are going to see how we can apply the knowledge that we have known for function, linear functions, quadratic functions, and exponential functions. So it asks you which one of the following are exponential. If it's asking you for exponential, if table values, when we know the ratio need to be same, so we need to do the division. And if from the graph we know that it should be either always increasing or always decreasing, okay? Not straight line. So for sure we know this one, no, because it's straight line. This one could be, but normally it should go continue, otherwise we don't call this exponential. So this one is no, because it didn't go continually. But for this graph, if it's a real-world application, it could be exponential functions. But if it's just not a real-world application, then the exponential should be keeps going, because you have one asymptote is closer to that line, but will never ever cross it. And we are going to do this one. So this one, x at exponent, so we know, okay, the variable is at exponent, it is exponential functions. Exponential function. And this one variable at base, so it's not exponential functions, it is quadratic, because the highest degree is 2, so it's quadratic. Now we are going to see the two tables. So for this one, we are going to see each of them. The first difference is 25 minus is down 10, down 10, down 10. So if you know the first differences are same, then we know it's not exponential. same, then we know it's linear, so it's not exponential functions. And for this one, first differences won't be same, so we are going to see the ratio. Okay, try the ratio means 64 divided by 51.2, 80 divided by 64, 100 divided by 80, and see if it gives you the same number or not. So this is 1.25, 80 divided by 64, it will give you 1.25, and this one 64 divided by 5.50. So we do the calculation, it gives you 1.25. So the ratios are same, then this one it is exponential functions. So exponential functions, one is table values, you check the ratio, and for the graph it should be increasing all the time or decreasing all the time, then it is exponential. So we go to the next one. So this one is asking you for the linear, quadratic, or exponential again. So we are going to try to do the first differences because subtraction is always easier. So we are going to see 238 minus 250 is down 12. This one down 36. This one down 60. Let me check the second differences. We always try the differences first. This one down 24. This one down 24. Then we know, okay, it is linear. Oh no, quadratic. Because second differences are same. It's quadratic. Okay. And for this one, we are going to see this one differences is 16, 24 up, 36, and differences will be 8, 12, so it's not. Then we do the division, okay? 48 divided by 32, it will give you 1.5. 72 divided by 48 give you 1.5. 108 divided by 72 give you 1.5. Then we know that it is exponential. So we know this one is exponential because ratios are same. And the last one, we do the first differences first. So 1 minus half give you half, 2 minus 1 give you 1, 4 minus 2 give you 2, 8 minus 4 give you 4. You will see it's repeating, so you don't need to go further. The differences won't be same. Then we do the ratio. Ratio means divide. 1 divided by half give you 2. 2 divided by 1 give you 2. 4 divided by 2 give you 2. 8 divided by 4 give you 2. So they are same. Exponential again. Exponential functions. So that is how you get it from table of values. Okay. Now it's asking you to fill in the chart, sketch it. When you are doing sketch, you are going to use a table of values. So for example, we give x, y value here, -2, -1, 0, 1, 2. We sub into 2 to the exponent x. You will have 0 0.25, 0 0.5, 2 to the exponent 0 is 1, 2 to the exponent 1 is 2, 2 squared is 4, then you sketch it. It's kind of like this. So this is a 1, okay? Then domain will be -infinity to +infinity. Y value is from 0 to +infinity. X-intercept, no. Y-intercept is always 0, 1. Interval of increasing is always go up, so increase. Increase interval is from negative infinity to positive infinity, all the way up. Asymptotes will be the x-axis. It gives you the y equals 0. So this is for y equals 2 to exponent x. Then we do the same thing, create table values. Negative 2, negative 1, 0, 1, 2. Sub in 3 to the exponent negative 2 give you 0.11. 3 to the exponent negative 1 is 0.3, then 139. So you do the graph, roughly, it's just steeper, okay? So this one will be same as front, okay? Same as y equals 2 to the exponent x, there's no change. And this one, y equals 1 or 2, so table of values, negative 2, negative 1, 0, 1, 2, sub in, it will give you 4, 2, 1, 0 0.5, 0 0.25. It's just flip this row. Then you will see it's going to be go this way. Okay, this is one. So the xy domain will be same. Y is negative 1, sorry, is 0. Will be 0 to the exponents, okay. So negative infinity x, positive infinity, y is above the x-axis, will be from 0 to positive infinity, x-intercepts, then this graph will approach x-axis closer and closer, but never ever cross it. And y-intercept is same, 0, 1, is not increasing. Decreasing means from left to right, it's go downhill, and it is decreasing, okay, decreasing all the time for negative infinity to positive infinity of x, all decreasing. Then the asymptote is same, is y equals 0, okay. That is for linear, quadratic, and exponential. And on the delta mass, you are going to see more functions, so I will show you that. So on delta mass, it has more than linear, quadratic, and exponential. It has other 4 functions I want you to know, but you're not going to have it on your quiz or somewhere. So linear is straight line, quadratic is U-shape, exponential is always go up or go down and approaches to a line but never ever cross it. And the cubic is just from the left, it's kind of like your linear, curve it a little bit, okay? A linear equation, curve it. And the cube root is just you turn this one, flip it, flip it in the y equals x, reflect it, then it just turn it to this way, okay? This is cube root. And the square root is just you rotate the quadratic 90 degrees, but only have one branch instead of 2. This is square root. And yes. X value is just similar with your linear equation, but flip the bottom up. So this is x value is U-shape, but it's straight. It's x value. So linear, quadratic, exponential is what you need to know, and other 4 is just extra, okay? You could use this page to help you to identify that the functions. So like I said, so you can use this page to help you to identify the functions, which type of function it is, and I'm not going to put it on a quiz. On a quiz maybe, but not on a quest. Okay. okay, because Christ will contribute more to your final mark. So it's beyond the grade 11 stuff. But I really want you to know the linear, quadratic, and exponential function, what shape they are, okay? And that is all for this analyze functions lesson, okay?